Okay, so today is your first day without me in terms of learning and kind of reviewing some stuff we learned in Chapter 6. So go ahead, take a second, get started. Hopefully you have your ChemCatalyst notebook with you. Copy down the ChemCatalyst just like we normally would have, and go ahead and try and answer it. All right, so it's asking you about electrons in the highest energy level or the valence shell. All right, so you could use your electron configurations to help you with this, or if you remember the trick, hopefully you wrote it on your periodic table. But go ahead, pause the video for a second, and we'll kind of come back and go through this together. All right, so now that you've gotten a chance to try this on your own for a little bit, hopefully you actually tried it and aren't just getting the answers from me. All right, but if you remember, it's going to be really important with this unit. We want kind of a shortcut of how to get the number of valence shell electrons, because they're going to be the ones doing all the bonding. All right, so for each of these elements that you were kind of asked to find, hopefully what you did is you looked at their group number in order to figure out the valence shell electrons. So you could have, for something like sodium, you could have done its electron configuration. For sodium, we know if it's a neutral atom, it has 11 electrons in its electron kind of cloud. All right, so you could have gone through and gone 1s2, 2s2, 2p6, and then finally 3s1 would be the end of its electron configuration. All right, and so if you look at, okay, the highest energy level, we have 1, we have 2, and so the highest one would be 3. All right, and so we know, looking at that there's only one electron in the highest energy level or the valence shell. All right, but if you also look at your periodic table, it's also in group 1A. So group 1A is telling you kind of a shortcut that sodium only has one electron in its valence shell. All right, and that works for all of these other elements that we're going to look at today. The only element that doesn't work for is helium. And that's because even though helium is a noble gas, it's in group 8A, but helium we know only has 2 electrons total, so that doesn't really work out. All right, but if you did the rest just like that, you would have seen chlorine, a halogen's in group 7A, so we'd want to say it has 7 valence electrons. Both sulfur and oxygen are in group 6A, so that kind of was an easy one hopefully for you. All right. If you look at silicon, on the other hand, so not in the same group, all right, silicon is actually in carbon's group, so 4A, all right, aluminum is in group 3A, beryllium's in group 2A, and finally phosphorus, right below nitrogen, is in group 5A. So that was kind of an easy way to answer this question. Hopefully you caught that. Otherwise, we'll have a lot of chances to practice that later on. Okay, we're going to go ahead then and start a little bit of review of some of the previous topics we had in Chapter 6 and even before that. So go ahead, get out your notes. We're going to kind of switch gears. All right, a little bit of review. So hopefully, again, you're kind of thinking back on your own notes, what we did in class as we kind of went through this, but in case you aren't, just at least get down the notes if you don't have them already. All right, so a little bit of review. Again, we just talked about valence electrons, but hopefully you have written down somewhere that these are the electrons, in the highest energy level. All right, which means, again, if we think about where our energy levels are, they're kind of on the outside, meaning that they're the easiest to get to, all right? That means they're the easiest maybe to take away, or maybe that's where we're going to gain electrons. Later on, we'll even talk about sharing electrons. But either way, these are the ones that are going to bond or react, all right? You can think of them as being lost or gained. These are the ones that just do everything. So the ones on the inside are not going to be super mobile, all right? But our valence electrons have that opportunity, all right? So these are the ones we're really going to talk about a lot in these next couple chapters, all right? Hopefully you remember, going back, which elements are non-reactive, all right? Another way of thinking about this question would be to think what elements do every element want to be like. So what's kind of everyone's goal on the periodic table. Hopefully remember that every element on the periodic table is trying to have the same number of electrons as our noble gases. All right, so if you didn't already have that written down somewhere, all right, or if you didn't have that on your periodic table, remember that all of the elements on the periodic table are going to lose electrons, gain electrons, share electrons, do whatever they can so that they eventually have the same number of electrons as a noble gas. All right, and if you remember our little trick from the ChemCatalyst, all right, then what that means is that for most elements, all right, that usually means that they're going to have 8 valence electrons, all right, because they're in group 8A. The only exception again is helium, who only has 2 electrons total. All right. Last for this part, how many valence electrons do noble gases have? Hope I already answered that for you. So again, based on their group, all right, most of them have 8 valence electrons, unless you're helium. All right, and then helium only has 2 electrons. All right, so again, this is all just kind of reviewing, so hopefully you already knew all this before I started talking. All right, next up, hopefully you remember the difference between something that's a cation and an anion, and hopefully you remember what an ion is just in general. All right, so remember an ion is just anything with a charge, so any atom, all right, that has a charge, all right, and then we just get more specific with that. So when you're a cation, this means you have a positive charge, all right, so you have a positive charge. If you're an anion, that means you have a negative charge. Remember, if you're a cat person, this is an easy distinction to remember. If not, then we might have to try a little bit harder, all right? But cations versus anions, just kind of want to have that in the back of our minds as we kind of go on today, because we're going to be talking about ions quite a bit the next couple days. All right, this one we haven't actually maybe discussed exactly in class, but we have brought it up quite a bit. All right, the laws of attraction. This is kind of anyone who's watched a good rom-com lately. All right, this is that idea that opposites attract. All right, so the super nerdy girl ends up with a super jock guy or something like that. All right, this idea that opposites attract means basically, in terms of our cations and anions, it means that positive things are going to attract negative things. And hopefully you already knew that, and hopefully we've said it enough times in class that that's not really a surprise to you. But just in case, make sure you've kind of got that in the back of your mind. Okay, so positives attracts negatives. Like charges would obviously repel one another. All right, you're ready. You've got all your background information. You've got your notes hopefully in front of you, so we can really get started with the new material. All right, so go ahead, go on to the next video, and we'll kind of start discussing our brand new topic in Chapter 7. All right, good luck.